Hey there, universe nerds. Imagine if you could take a shortcut through the universe. Instead of traveling for thousands of years across the stars, you slip through a tunnel and pop out instantly on the other side of the galaxy. That's the idea of a wormhole, a tunnel through space and time. It's a concept that feels like science fiction, but it's also grounded in real physics. Today, we're diving into what wormholes are, where the idea came from, and whether we might ever use them to travel the cosmos. The story of wormholes begins with Einstein's theory of general relativity. In 1935, Einstein and physicist Nathan Rosen described what we now call an Einstein-Rosen bridge, a mathematical solution where space-time connects two distant points through a tunnel. Think of space as a sheet of paper. If you fold it and punch a hole, you can connect 2 points instantly. That's the wormhole, a cosmic shortcut written into the equations of gravity. But just because math allows it doesn't mean nature builds it. Wormholes, if they exist, would be incredibly unstable. They might collapse before anything could pass through. Some theories suggest you'd need exotic matter, a form of matter with negative energy, to hold them open. Without it, the walls of the tunnel would slam shut instantly. Right now, exotic matter is purely hypothetical, but quantum physics hints it might exist in tiny amounts. Over the decades, wormholes became a favorite in science fiction. From movies to novels, they're depicted as glowing tunnels connecting distant worlds. But real physics says they wouldn't look like that. From the outside, a wormhole would just appear as a black sphere, like a black hole. Only by entering would you discover whether it connects somewhere else or just leads to destruction. The romance of wormholes is that they might solve the greatest challenge of space travel: distance. Could wormholes allow time travel? The equations suggest it's possible. If one end of a wormhole experiences time differently than the other, say by moving near light speed or sitting close to a massive object, stepping through could send you not just across space, but across time. That makes wormholes even stranger, not just cosmic highways, but potential time machines. Of course, this raises paradoxes, like meeting your past self, and physics isn't sure whether nature permits them. So far, there's no evidence that wormholes exist. Astronomers have looked for unusual gravitational effects that might betray their presence, but nothing has turned up yet. If wormholes exist, they may be microscopic, smaller than atoms, flickering in and out of existence at quantum scales. Or they may be vast but rare, hidden across cosmic distances. Either way, they remain one of the universe's most intriguing what-ifs. Even if we found one, using it would be a whole other challenge. The tidal forces near a wormhole could stretch matter apart. Radiation could fry anything entering. And stabilizing it with exotic matter might require more energy than an entire star produces. Traveling through wormholes is still in the realm of theory, not engineering. But the fact that they're even possible in equations keeps scientists and dreamers alike fascinated. What makes wormholes so captivating is that they sit on the edge between science and imagination. They show how relativity bends reality in ways we can barely grasp. Whether they're real or not, they remind us that the universe is stranger than fiction. And if someday we do find or create one, it would revolutionize everything: travel, communication, even our understanding of time itself. So, are wormholes real? We don't know. Right now, they live in math, in theory, and in our imaginations. But the idea that the universe might hold hidden tunnels across space and time is irresistible. Next time you look up at the stars, remember, the straight line may not always be the only path. Somewhere out there, space itself may be folded, waiting for us to discover the ultimate shortcut.